Okay, so rationalizing the denominator means what I would say is rational and radical are opposites of each other. Rational, I always think of fractions. Radicals, I think of the root symbol. So we want to rationalize the denominator, meaning we don't want these radicals in the denominator. Doesn't matter if they're on top, we just want to get rid of them on the bottom. And so what we're going to do is we're going to multiply. We're going to multiply the denominator by something that would allow us to solve the radical. Like, you can solve what is the square root of 4. That's 2. Or what's the cube root of 8 is 2. So you can find an answer of a whole number. And so we want to multiply to make them into something that can be solved. So for example, here I don't know the square root of 7, but I do know that if you multiply this by 7, it'll make 49. So then I can find the square root of 49, which is 7. So we're going to multiply this denominator by the square root of 7. And what you do at the bottom, you have to do the top. Do the same thing up here. So now, on top, we have 2 times the square root of 7. And that can't be completed. We don't know the square root of 7. On the bottom, we have square root of 49. And this part, we can complete it. Square root of 49 is 7. So our final simplification of this, or rationalizing it, is that 2 times the square root of 7 over 7 means the same thing, but we now no longer have the radical in the denominator. So if we come over here and we say, okay, what can I multiply by to make this solvable? Well, this is a square root. We don't have any x squareds in here. So what we're going to do, multiply by x on both levels, square root of x, excuse me. And when you do that, the top becomes 3 square root x over the square root of x squared. X times x, x squared. So now the square root of x squared is just x. So our answer is 3 times the square root of x over x. Then we come over to this one. This is actually a cube root, and so we need this to become something that we know the answer to. There's multiples of 3. Let's see, 3, 6, 9, 12, 15, 21, 24, 27. Here's one right here. 3 cubed is 27. So I want to make this become 27. And I want this to become x to the third so that I can follow through with getting rid of the radical. So I'm going to multiply this by the cube root of 7. Excuse me, not 7, 9. 9. Because 9 times 3 is that 27 that we were looking for. And then this needs 2 more x's to have a group of x to the third to complete it. So 2 more x's. So we're going to multiply by the square root, or cube root, excuse me, cube root of 9x to the second on both levels. So now what we have is x squared on top times the cube root of 9x squared. And we can't complete any part of this because we don't know the cube root of any of those. And then on the bottom, we have the cube root of 27x to the third when we multiply these together. So now we can complete this part. The cube root of 27 is 3. The cube root of x to the third is x. So our answer then on top be our x squared cube root of 9x squared over 3x. And then in this case, I could reduce this. I have 2 x's here that are not in a radical, and I have an x here that's not in a radical. We can only reduce the x's if they're in the same situation. So if I had a cube root of x down here and I have cube root of x up there, that we could reduce. But since these are not inside the radical, we can do our normal simplifying where you subtract the exponents and so forth. So if we get rid of this x, which is just getting rid of one x, and we get rid of one of them up here, we only have one left. So then we have x times the cube root of 9x squared over 3.